Hope you're all doing well.
Hello.
Thanks for coming to this session, Secure Container Workflows with Anchor and GitHub Actions. I'm glad you all could make it. My name is Steve Winton. I am a member of the partner engineering team at GitHub, where it's my pleasure to work with GitHub's many wonderful partners and help them and work with them as they bring new products and services that work with GitHub to market for our shared customers. I've been working for the last several weeks with our partner, Anchor, and we're excited to show you what we've been working on today. Zach?
So my name is Zach Hill, and I'm the principal architect at Anchor, and looking forward to kind of showing you this new Anchor container scan action and how you can use that to bring security to your container-based workflows. So today, we'll start off talking about some of the opportunities and challenges that arise in these new container workflows. I'll then talk about the capabilities of the Anchor scanning system and how it does container scanning analysis and policy evaluation. Then I'll cover quickly the Anchor container scan action itself, so how it works and what it's doing in your actions workflow. And then we'll see how to add that scan action into your own workflow so that you can be scanning the container artifacts that are coming out of your actions pipelines. So at a high level, we really like containers, right? They've really helped us increase development velocity by providing things like reusability, isolation, so you can run many versions of an application right next to each other without worrying about configuration conflicts, right? It enables faster testing. You can test multiple versions or multiple sets of dependencies all at the same time. And it provides a consistent development experience all the way from, say, onboarding new developers, where you can quickly spin them up with your application stack on their laptop, all the way through the CI, testing, and ultimately deployment. And this consistency and brings significant ease of ingress for new technology. So it's much easier now to bring in new applications or components of your application stack and get them directly from testing and into production. And so overall, this is increasing the development velocity, which is great. So development and DevOps teams feel empowered to kind of move fast and be able to break stuff because they're confident that they can push out updates quickly and reliably without having to babysit their infrastructure and worry about how hard is it going to be to roll things back. So we'll kind of show that in action here.
So as well as my day job at GitHub, I also have a bit of a side project going at the moment where I'm a web developer for a new enterprise called TopSocks, which perhaps many of you have heard of. It's basically the top destination for socks on the internet. I'm sure you've heard of us. If not, check us out. I have been working in my spare time really, really hard on a new feature that is pretty important to my marketing team. There's quite a lot of pressure around this to get this out the door. It's an animated GIF service, and it's going to power all of the animated GIFs that our marketing team needs on our e-commerce front end. So I've been working super hard on this. I need to get it out the door ASAP. And here is the repository. Now, fortunately, I had the foresight to wrap this service in a container. So it's all neatly containerized here, as we can see. So this gives me confidence that when I ship this, the code that I've been running on my development machine is exactly the same as what lands on master. So, and in addition to being containerized, I've also been extremely clever in using GitHub Actions to create this build and deploy pipeline. And I've got several steps in here that you can see running tests. I'm doing even an audit of my NPM packages that are in my service. I'm building my container. And if all of that is successful, I'll ultimately deploy that container. The deploy step here involves pushing it to GitHub Packages, where then a separate process will see that. It will pick up that new container, and it will push it off to production for me. So it's all fully automated, really repeatable, a really reliable process. And this is going to help me move fast, which I really need, because like I said, there's a lot of pressure to get this done right now. So here I am with my pull request that's like 90% of the way there. Opening this pull request is actually going to trigger off all of my actions, all of my checks to run for me, and it's going to give me that kind of added amount of confidence to make sure that it all goes well. So here we see the checks now being kicked off for my pull request, and we can jump in and check out the details and make sure it's going OK. So this should all start running here in a second. And if anything does fail, then that's going to block my pull request. I won't be able to merge anything. Checking out the code, that passed, don't expect that to fail. I'm caching my node modules, which gives me a little bit of a performance boost if anything does go wrong. I need to do it again. I won't need to do that step again. It looks like this time we do need to install those packages, so it'll take a couple of seconds to do that. And then my tests are going to run. I've got some tests in there. I could probably boost those a little bit with my coverage. And then most importantly, my audit step here. So 0 vulnerabilities in almost 900,000 packages. It's crazy. But yeah, 0 vulnerabilities there, which is awesome. So I'm, with every green check mark that I'm getting here, I'm just getting increased confidence in the quality of this release. So my image is being built now. I do see a few warnings there, but I don't think I need to be too concerned about that. I saw the same thing on my development machine, and it was fine. So let's just wait for the build to complete here. In just a second. OK, and right, because we're on a pull request here, I'm not actually going to do a deployment. Once this pull request merges, we'll do the deploy at that step from master. So this is all green now. I'm feeling pretty good about this, so I think I can hit that merge button. It's a big decision, but I do feel good about this, so yeah, I think we can go ahead and merge this now. Thinking about it. Let's merge. Let's do this. There we go. Yeah, and there's my email address. And we can delete the branch. We don't need that anymore. So yeah, like I said, now this has been merged to master. That merge commit will run another scan on that merge commit, and then that will get pushed out to production, get picked up by a separate process which will do the actual deployment. So all that to say, this process of running automated checks, of running an audit on my packages, of running my tests, pushing the container out to GitHub packages, it's allowed me to move fast. It's allowed me to get this new service out to production really quickly. Basically, I'm pretty happy at this point. I'm going to tell my marketing team that the new service is ready. They'll be ridiculous. They wanted it yesterday, but I think they'll be amazed that it landed today in production. And I think at this point, I can pretty much relax, give myself a pat on the back, and probably finish my working day early. So thanks for coming, everyone.
We're done. But I, too, am moonlighting for Top Stocks, and my job is security. And I say, great job, Steve. I was very happy to see that NPM audit, but what we deployed was actually a container. And so what I didn't see is any understanding and analysis or policy around what can be in that container itself.
OK, so maybe I haven't finished my day just yet. So I guess my security officer might have a point. Maybe there are some additional things in my container that I might have overlooked, even though my 900,000 packages didn't have any vulnerabilities. Yeah, perhaps there is something else in there. But I'm just a developer. I don't really have time. I'm trying to meet our business requirements. I'm trying to keep my marketing team happy. I feel like now I've got the security officer kind of asking me to do extra things as well. I'm already doing all of this stuff. And it's kind of getting a bit overwhelming, like all these choices that I need to now make. What is a good base image to start building from? I don't really know, to be completely sure. I want to be able to ship confidently and with high velocity, but I feel like this is going to just slow me down. All this kind of additional complexity, responsibility. I'm not sure what I should check. I'm not a security expert. Honestly, I kind of wish that I could outsource this problem to someone else.
And so that feeling is kind of emblematic of some of the security challenges that we see with these containerized workflows. And more generally, this ongoing transition from dev to DevOps and DevSecOps, right? As developers are getting the tools to move very quickly and push things through to production very fast, it's also actually making the choices that are made earlier in the development process even more important in terms of what actually gets deployed in production. So an early decision by a developer to just grab a random image, I need a database, and I'm going to grab this and stick this into my deployment template. Suddenly that makes it all the way through to production without the proper checks, and it may be violating a lot of different security or compliance requirements that the organization has. So this kind of leads to the question, what about security review? And where does security reviews fit in these workflows? Who owns them? And how do you scale these processes for microservice architectures that are becoming so popular, right? You might be pushing tens, hundreds, even thousands of services out with multiple updates per day, right? You've got a very polished deployment pipeline. Every merge is going and resulting in a new commit, a new version of the software being pushed out to your customers. And so this overall leads to a really large inventory. So you have a bunch of container images out there, potentially lots of churn, and even more specifically, really short container lifecycle. So a given version of your software may only be running for days or a week, and that has implications on the back end when you need to do security audits and security reviews for understanding kind of what was running and where. And so ideally, we want to assist this with tooling. And the first step in this tooling and helping kind of bridge this gap is understanding the container content kind of in a deep way. And we don't want to have to do this with a manual process or a manual review, but it's important to understand that there's a lot that goes into these containers besides just the application code, right? So there's build metadata that comes in from the Docker file during the build step. We saw a fairly straightforward Docker file there, but it's not uncommon to see Docker files that are 50, 100 lines with lots of different operations, pulling in tarballs from various sources within the organization and dropping those into the container, for example. That includes the software packages that get installed during your build, as well as any underlying, what I'll call OS packages, but usually they're things like libc, right? They're user space libraries that are needed to run maybe your language framework, right? Node or Ruby on Rails. Those have low-level dependencies as well. There's also configuration files that will define how these various processes run, the OS files themselves, and even, in some cases, application data. So things like machine learning images we see that often get front-loaded with a pretty big corpus of data during the container build itself. And so all of this means that you have a lot of different classifications of things that are in the container, and you need to understand that and be able to do the appropriate security checks against all of those things to make sure that what you're pushing into production meets all of your requirements for security, compliance, and audit. Security is more than just scanning a thing for vulnerabilities. It's about understanding the audit trail. So where did things come from? Where did they run? Which commits of code resulted in which containers and which artifacts eventually ended up in production? It's also about enforcing organizational best practices and configuration. So things that help your processes further down the line, say required labels in your Docker file, right, that are used to track deployment later on, or specific health checks that you want to ensure every container has. And so enforcing this, and that can impact your security stance as well. So the best way to address this overall is through policy and automation, right? So you want to make sure that you're scanning and verifying the unit that you're actually deploying, which in these cases is the container itself. And this has a couple of other benefits as well, because you can use the same approaches for things that are runtime dependencies of your application stack, your databases, message brokers, caching systems. All of this can be analyzed the same way, even though they're delivered as containers, but they're not actually your source code. So what we see in real deployments is often, the application that you're deploying is part of a broader stack and your application code may only be a small portion of the total deployment surface that gets pushed out with each update. And we use policy here to help communicate and enforce requirements. So this is how Steve, as the developer, doesn't have to understand all the requirements and exactly what to check. That can be a process that's coordinated between the development team and security team, if you're lucky to have one, or by somebody in the security organization. And then it's very clear what the requirements are, and it's very clear that those will get enforced automatically on every commit. And ideally, you'd even be able to keep this policy with the application code, furthering that coupling and that communication between the various teams. And for automation, we bring that in, and we want to automate this process so that developers get feedback very early in the process. For example, on your push or your PR so that developers can address these known issues immediately and ensure that they're not wasting further CI cycles or deployment cycles and tracking things back after they've been deployed. You can catch it early in the workflow where it's most effective, most efficient in terms of cost and time. And then the last aspect where this is particularly advantageous with things like GitHub Actions is audit. So we can combine the results of these scans with the commits that generated them. So it creates a natural and nice audit trail through the system where we can see each change that comes through the code resulted in this change to the containers that it generated, and actually these compliance and security checks that resulted. So that's where Anchor, the container scan action, comes in. So what we've done is we've built a scan action that you can execute in your GitHub Actions workflow that takes the Anchor technology, which I'll go over momentarily, and embeds that into your Actions workflow so that you get a consistent policy-based approach to validating the containers that are moving through your pipelines. So Anchor, at its heart, is a container analysis and policy evaluation tool and platform. So it takes containers, it cracks them open, tries to classify and understand all the content that's in them, and then provides a policy language where you can define checks and audit trail on each of those aspects so that you can both focus your security and compliance efforts, as well as get a nice audit trail of what was found in the container. So first, the thing that most people understand right away is vulnerability matching, right? So Anchor can do vulnerability matching against the OS packages, so things like RPMs, debs, your distribution packages, as well as language or application packages, NPMs, Ruby gems, Python files, Java jars, things like that. So it can do a full suite vulnerability matching. And it can do that because it deeply understands all the content that's in the container, and that includes enumerating all the OS packages and language packages, but also extending down into the guts of the file system where we do a full scan of all the files, checksum every file in the container, and so we can understand change control over time and between images. And then this policy language lets you define checks on the results of that scan. So things like best practice validation, looking at the Docker file that was used to build the container and then ensuring that it has certain best practices. Or, for example, whitelisting or blacklisting application packages, maybe NPMs or OS packages. You want to make sure that libSSL is at least some version or greater, right? You can enforce that in the container scan itself. Anchor also has the capability to do credential enforcement, so it will look at the content of the container and ensure that there's nothing in there that looks like it was a accidentally leftover credential. And these things can result from either it being directly in your code repository, which we hope you've got other tooling further up the chain to help identify that you're not committing keys into your GitHub repo, but that can also come in with build environment variables that are used or maybe logged during the build process itself and can end up in containers that way. So it provides a rich and kind of very flexible policy language that lets you define the acceptance criteria and what you want to check for each of these kind of aspects of the container content itself. And here, next I'll provide a really short example of the kind of policy rules. So Anchor policies are just JSON documents, and they have sets of rules, and they have parameters. So here, this is extracted from the default policy that ships with the container scan action that we're talking about today. And at the top there, you see the action is stop. So if this rule fires, it can block a build. And then there's some parameters. So you see the gate that we're evaluating. The thing it's doing is a vulnerability check. At the bottom, I should have changed the ordering there. At the bottom, it's triggering on packages. So it's looking for vulnerabilities in packages within your container. And then there's a bunch of parameters. So what kind of package should it match against? What kind of comparison should it use for the severity of the vulnerability? And a limit on severity. So what this one is actually describing is a stop action for any vulnerability that's found that's either high or critical severity, and for which a fix is available. So that last parameter, that name value pair at the bottom, says fix available is true. So this is helping us reduce the set of the noise in the system to things that you can actually resolve because there's a fix available, and you can update your container to resolve that issue. That's just one small example of one rule. There's a whole bunch more. Feel free to check us out on the web later for kind of a better listing of that, or come find me after the talk. But at a high level, the Anchor policy has several features that we think make it really useful in terms of identifying actionable issues and helping you build better images as a result, and not just ingesting a giant list of vulnerabilities that somebody has to manually filter through later and figure out whether those 27 medium vulnerabilities actually matter to your application or not. And that's around the parameterization. So you can kind of specify the kinds of checks that you want, the parameters, including things like CVSS severity, whether or not a fix has been available, how long a fix has been available, how long an image has had a vulnerability, there's grace periods, all kind of these parameters help you focus in on what matters most for your organization. We also support inline comments. So for each rule, you can set a comment that helps you provide context. So anybody reading that policy, they can see that this is why this rule is in place. We also have a capability of doing whitelisting directly in the policy. And this is important because, as we know, no policy will ever be perfect. There will always need to be exceptions. And this lets you track kind of those exceptions to the rule within the policy directly. And again, ideally tying this directly into the source repository that's building the container itself. And lastly, the way Anchor evaluates policy is very audit-friendly. So it will evaluate every single rule in the policy and give outputs for every single rule, whether that's a stop action, as we saw. Anchor also supports two other types of action, which are go and warn. So you can craft the messaging for the output of that policy. Maybe you just want to run a bunch of checks and record the results, but not actually block your CI pipeline. So it's very flexible and audit-friendly in that way. So how does it actually work? Like, what does Anchor actually do? So Anchor Engine is an open source project that provides a stateful service that you make API calls and tell it to analyze images, and it fetches those images from Docker image registries, analyzes them, and provides an API for asking questions about, did it pass policy? What does it have in it? You get a notification if there's a change in the vulnerability status of an existing image, et cetera, et cetera. So it contains a powerful set of reports and queries and eventing, and you can integrate it into an existing action workflow using API calls, but often for a lot of GitHub users, this isn't going to be sufficient because they don't want to run yet another stateful service that they have to expose on the internet somewhere so that their GitHub action workflow can access it. And so we've wrapped that around what we call the inline scan, which takes all of that logic and composes it so that we can run it entirely locally as kind of a command line. So you just say, do the thing and give me the output. All right, so that makes it much more consumable. And it doesn't have any external dependencies, so you don't have to do any call-outs to any other APIs. No external services are required. But it's still fully featured in terms of its metadata and vulnerability checks. And for the scan action itself, the thing you actually run in your actions workflow, we've wrapped that inline scan around some inputs and outputs. So what actually happens when you invoke the Anchor container scan action is it's going to pull down a Docker image from our Docker Hub repo that contains all the vulnerabilities, and those get updated nightly, so you always have fresh vulnerability data. Then it does an unpack and deep scan of your container that you've told it, scan this container on my local host or in the GitHub workflow. And then it will do the security scanning, and then take those outputs and pass all that through the policy engine, ultimately giving you a pass or a fail. And again, to reiterate, this runs entirely within your CI, or in your actions workflow, and there's no external credentials. It doesn't hit any other service running outside of the workflow at all. So no data leaves your pipeline. So I'll just quickly touch on some of the input parameters for the action itself. And Steve will show us kind of later how we actually use this thing. But at a high level, I just want to highlight at the very top there, the image reference is really the only thing you need to give it. So you can call the action and say, analyze this image, right, with this tag that I just built locally. And it will do the rest. There's other things you can set, like whether you want to fail the actual actions build or not, based on the result of the policy. Whether you want to include a custom policy. So we have a default policy that ships with the action. You can always build your own policy document and use that instead. And so you have that level of flexibility. And the outputs, when it completes, are a bill of materials, which is all the packages specifically that it found. We don't dump the full file system yet. That's a little too verbose for most workflows. The list of vulnerabilities and the output of the policy check. And the intent here is that you can use these downstream in your actions workflow to do other logic. Maybe you want to file an issue because of some output, or you want to initiate a different kind of deployment, push it to a quarantine, or push it to a staging environment, those kind of things. And as an example of the scan action output itself, I've included, this is just a snippet out of one of the actual builds. And this is where the auditability comes in. Here we can see that that at the top, we actually have the image digest that was built, so you can trace that through your system. We have a status, which is pass here, and then actually showing the kind of output of each of the policy rules, organized here by this gate and trigger, and then some detail. So what this particular output is showing us is that one of our metadata checks has raised a warning that your Docker file looks like it's indicating that the container should run as root, right? And that's generally considered against best practice. We want to run as non-root. So that's an example. The default policy that we include with the action will fail on critical and high vulnerabilities with fixes available. So again, it's things that you can take action on directly and immediately without a lot of noise. Of course, you can expand this and customize it as much as you need to later on. And it will give you warnings for Dockerfile best practices, such as the one we just saw around the non-root, but also for missing health checks, or if it finds anything in the container that look like secrets. So now to show us how to actually add the action into your workflow, I'll hand it over to Steve.
Cool. Thank you, Zach. So that was quite an education for me. I think I want to incorporate this new capability into my workflow to get a more secure development process through policy and automation. So I found the action here on GitHub Marketplace, the Anchore scan action. And I want to definitely incorporate this, get the additional analysis, and have added security confidence in the security of my releases. So all that's required here is to grab the latest version, and there's a YAML snippet here that I can just copy, grab that, and paste it in as a new step to my existing workflow. So let's grab that. And I actually committed this earlier. You can see it here, the scan action that I've added in between my build step and my deploy step. So after a successful build, we'll do a scan of the image. I'm using the latest version of the action here. We're passing in the image reference, which is required so that the action can actually inspect it. I want to set the fail build option to true. So if there are any policy violations, then that does actually prevent the pull request from merging. And also, I'm passing in the path to my Docker file so we can do an analysis on the Docker file as well. So everything else is the same as before. The only thing that we've added here is this additional scan image step. So here's a previous run against the code that's currently on master. And we can see everything is green as it was before, but it looks like, so caching, installing, testing, the audit, the build is all green, but it does look like the scan image has reported a policy violation, which is unfortunate. So let's jump in and see what it found. So we can see, in the annotation, there's a failed policy evaluation, and then if we jump down and expand the details here, and just take a look, it looks like there are a couple of high vulnerabilities which were missed before, and it looks like there are some operating system packages that contain some vulnerabilities, which is unfortunate. And also we can see that there are some warnings as well from our Docker file, so we're using the root user. That's unfortunate, but at least I do have the confidence now that we can catch these earlier in our release process. And also generated from the action, we have a couple of outputs that are quite useful. We can see them at the bottom there. So we have this bill of materials, which is a JSON report of kind of a list of everything that's included in my image, and then our list of vulnerabilities, and also that policy check fail. So it's great that these are exposed as outputs by my action. That means they can be easily consumed downstream, and we could produce further reporting on top of that. But for now, I think what I want to do, because my marketing team is getting a little panicky now, I think what I want to do is just try and address this vulnerability to see if we can get a pass here. So let's see if we can do that. I have a pull request as before that I've started here. I've got a single commit on this pull request at the moment. It's just an empty commit that I used to just trigger a rebuild, and we can see that that is also failing. And now if I scroll further down, then because the CI is failing, I'm actually blocked right now from merging this pull request, which is actually kind of what we want. Wish I had this before. But let's see if we can fix this. So I'm going to jump into my branch here. And I think a sensible place to start would be the Docker file. So I'm going to open that up. And I see one of the first things that jumps out at me is that I'm building on top of this Node 8 Alpine base image, but I don't actually update any of the software packages that are on that image. So that seems like some low-hanging fruit there. I think I'm going to start there. So let's edit this file. And because this is an Alpine-based image, to update that, I just need to run a command, which is using APK. So let's run APK, if I can type. Thank you. APK update and APK upgrade is the command we want to run. So just check that looks good. And yep, we want to bake that in now to our container image. So let's commit that, and I'll commit it directly back to that address security vulnerability branch. So let's commit that and jump back to our pull request. And there's our new commit saying update Docker file. And again, this is going to trigger our CI process, which is in the queued state. So let's jump into the details and see how this is going. So because our time is precious, I'm going to temporarily suspend the constraints of time and space. And we're going to jump through some of this stuff. So the audit has passed again. We are this time in the build. We're updating the OS packages on there. The build passed, so everything is green as before. We can see that the caching step meant that we could skip the installation step, which is nice. And now that we're up and away and scanning our image and looking for any policy violations here. OK, so this time I'm pretty pleased to say that the scan has passed. And I see that there are still a few warnings in here, but most importantly, there are no policy violations. I think, maybe for a future version of this workflow, it would be nice to maybe consume these reports, consume those warnings, maybe create issues in my repo so I can track those later. But for now, everything is green. It looks beautiful, right? I also got a +1 from my colleague Thomas, who's on the team. So I'm glad someone else has also reviewed my pull request. Thanks, Thomas. I appreciate that. I'm glad I'm not in this alone. So everything is green. I've got my approval from my team. I've built my container. I've run my tests. I've done an audit, and I've done a scan. OK, now I do actually feel really confident in this release. So this time, I'm going to merge with added confidence. Delete that branch again. We don't need that anymore. And yeah, so I'm feeling really comfortable, really confident now with this deeper insight into my release process. It's still fully automated, still really repeatable, but it's also much, much deeper before, so we have confidence not only in the quality of our release, but also the security of it. So just to take a step back for a moment and to review what we just saw there, this is kind of the secure container workflow that we would advocate as a best practice. So what we've shown is on every push and every pull request, we're doing kind of our standard unit tests on the application itself. But we're also doing this kind of much deeper vulnerability scan on the app dependencies. We're doing a deep inspection of that container. And when all of that stuff passes, we can ship. So even though I'm not a security expert, I'm a developer, I can still ship with confidence and with high velocity, be confident in the security of my release and the quality, thanks to the Anchore scan action and GitHub Actions. And just to recap how to grab this, it's a simple 3-step process. Navigate to GitHub Marketplace, that's github.com/marketplace. Use a search there for Anchore, and you want to add the Anchore scan action step to your workflow. Like we showed you, it's just a matter of copying the YAML snippet and adding it as a step to your workflow.
Great. Thanks, Steve. So for more information on Anchore, you can find us at the link above. check out more information on the GitHub Actions for more interesting and sophisticated things you can do in your workflows. And if you want to engage us for the container scan action itself, that's also open source, and you can find that on GitHub as well, in the marketplace, which will then also link to the actual source. So check us out there, or find us after the talk.
Cool, that concludes this session. Thanks, everyone.
So that's it. Thanks.
Thanks for coming. We'll be around if you want to grab us for any questions, but have a great rest of the conference. Thanks, everyone.
Thanks.